Hi everyone, welcome to Tech Talk with Maritza. I build AI-powered systems for cybersecurity and intelligent workflows. Today, I'm inside a machine learning environment building a malware classification system using decision trees and random forest algorithms. This is the type of AI workflow used in modern cybersecurity systems to classify malicious activity, improve threat detection, and support intelligent security operation. Today's project focuses on malware classification using machine learning. Malware classification systems analyze software behavior and characteristics to determine whether activity is malicious or safe. In cybersecurity environments, decision trees and random forest algorithms are commonly used to improve threat detection accuracy and support intelligent security analysis. This is important because modern organizations generate massive amounts of security data, and AI helps automate the identification of suspicious patterns much faster than manual analysis alone. Behind me, I'm importing the machine learning and data analysis libraries required for this workflow. Pandas helps organize and analyze datasets. NumPy supports numerical operations and processing. Scikit-learn provides the machine learning algorithms and evaluation tools. Matplotlib is used to visualize the classifier results. I'm also loading the malware dataset into the machine learning environment. This simulates how enterprise cybersecurity systems process real-world threat intelligence and behavioral data before AI analysis begins. And here I'm doing feature extraction on the samples and targets, the relevant features and target labels from the malware dataset. In real systems, this helps identify malware behavior, network anomalies, fraud patterns, or suspicious user activity. Now I'm creating and training the decision tree classifier. A decision tree model makes decisions by splitting data into branches based on specific conditions and behavior patterns. This allows the AI system to classify activity step by step using logical decision paths. Decision trees are valuable because they are easier to interpret and explain, especially in environments where organizations need visibility into how AI decisions are made. Here, I'm testing the decision tree model and calculating its classification accuracy. This helps evaluate how effectively the AI system identifies malicious behavior patterns. Model evaluation is critical because organizations rely on accurate AI systems to support security operations and reduce false positives. Now I'm building and training the random forest classifier. Random forest improves prediction performance by combining multiple decision trees together into a stronger ensemble model. Instead of relying on a single decision path, the AI system analyzes multiple trees simultaneously before making a final classification. This creates a more robust and reliable cybersecurity detection system. This same concept can be applied to intelligent automation systems, predictive business platforms, and AI-powered operational monitoring environments. Random forest combines multiple trees into an ensemble model, creating a more robust and reliable cybersecurity detection system. In our lab, the random forest model outperformed the decision tree, strengthening our intelligent threat analysis. Here, I'm visualizing the accuracy comparison between the decision tree and random forest classifiers. The random forest model achieved slightly higher accuracy because combining multiple decision trees improves stability and predictive performance. This is important because organizations often compare AI models to determine which system performs best for real-world deployment. As an AI systems engineer, this helps me understand how to design stronger and more reliable intelligent systems. Now I'm displaying the final classifier accuracy scores. The results show that both models performed at very high accuracy levels, with the random forest classifier slightly outperforming the decision tree model. This demonstrates how machine learning can successfully support malware classification and intelligent threat analysis. In real organizations, systems like these help cybersecurity teams automate detection workflows, improve operational efficiency, and strengthen security monitoring environments. Here I'm saving the completed machine learning notebook. This notebook contains the full AI workflow, including data processing, feature extraction, decision tree classification, random forest classification, performance comparison, and machine learning evaluation. Maintaining organized AI workflows is essential in real engineering environments because reproducibility, documentation, and scalability are critical for enterprise AI systems. This project demonstrates how decision trees and random forest algorithms can be used for malware classification, cybersecurity analytics, and intelligent threat detection. As an AI systems engineer, these are the types of machine learning workflows I can integrate into cybersecurity operations, intelligent automation systems, predictive analytics environments, and AI-powered business platforms. My focus is building systems that are not only automated, but capable of learning from data, identifying threats, improving decision-making, and adapting intelligently in real time. If you enjoy AI, cybersecurity, machine learning, and future-focused engineering content, make sure to like, subscribe, and share. AI on Self channel for more AI content on Tech Talk with Maritza.